Welcome to everybody who decided to join us for Sano seminar. To some extent, it is a seminar in a hybrid mode in the sense that research teams in Sano are sitting usually in front of one screen. So you should sometimes multiply by 4 number of people who are indicated as participants. And in Sano, we still have almost the full team working in preparation for many conferences, including VPH conference in September, but there are many other, and probably holidays will be in August. So we'll have another seminar in a week from now. And today we have a very, I think, interesting topic. Namely, it's about how AI was implemented in something which looks like a quite large system, namely UK National Health Service. And we have with us two speakers. We have with us John Taylor. John is consultant clinical scientist at Sheffield Teaching Hospital, and he is also a honorary lecturer at the University of Sheffield. So he has a lot of interesting publications and a lot of, let's say, awards, and which were gained after he completed his PhD in 2019. He's also a co-chair of the Institute of Physics and Engineering Medicine AI Group. And we have also with us Dr. Stephen Wood, who is head of scientific computing and informatics at the Sheffield Teaching Hospital. Steve is our friend for a long time. We have started to work together on VPH project. I think that it was something like 15 years ago. And then there was another project. And so since 2015, he is the role of research informatics, leading the research informatics at the Sheffield Hospital. So this is about our speakers today. John and Steve, floor is yours, and screen, of course.
Okay, thank you. I fear the title of this presentation isn't going to give you as many answers as you'd hoped. It's still very much a journey for us in the UK, as I suspect it is for everyone everywhere. It's such a changing landscape that we are struggling to keep up scientifically. Legislatively, they're struggling even more. So we're going to start by, I'm going to give you a bit of an introduction of where the NHS is and where us as a hospital are with sort of legislation, guidance, what we think we can do and what we shouldn't do. John's then going to take you through some real examples of how we're trying to validate, test and deploy some imaging applications. Then I'm going to come back in and discuss some of the problems operationally with deploying these tools, some of the unintended consequences of bringing them into maybe an organization that isn't quite ready for them. And then John's going to come back at the end with a kind of framework that we've produced just within STH, within our own hospital, to try and guide us through what a safe implementation of an AI type technology might look like. So that's me first. First of all, I'm going to go through the checklist that you should probably go through with any product development. First test is, can we do this thing that we want to do? Can we build AI tools that we believe are safe to use clinically? I think we can. We've got lots of stuff already in place through the medical devices directive, software as a medical device. But we probably need a little bit more than that, is the upshot. The life cycle of these products is very different to the ones we're used to traditionally dealing with. And so we need to maybe build out some things alongside the current frameworks that we have. Should we do it? Well, here's the kind of classic NHS. You could find 100 of these statements in the UK on NHS websites. You'll find them across the world on any topic you can care to mention. AI is going to transform everything. It's going to be fantastic. It's going to save us loads of money and make everyone better at what they do. I have to say, I probably do agree with that. Fundamentally, it's a huge opportunity. It's also a little bit terrifying if it's not controlled properly. I think the world might be starting to wake up to that realization. In the UK especially, because we're a public body, because we're funded nationally and centrally, we do have to think about what our patients want us to do. There's a bit here about, what the rules might be, equity, bias, all those things that you're probably kind of quite used to dealing with when we're talking about AI anyway. But it is absolutely true now that increasingly over the last 12 months, we are getting freedom of information requests from patients about their own care, explicitly asking if we have used AI anywhere in their treatment. Now, to be fair, these are probably people who have had a problem with their treatment. So they're kind of, looking for all the evidence they can to take a legal step forward. But this is a problem for us because formally we don't log whether technologies have AI components in them. Sometimes they get snuck in by manufacturers and we don't know. The point is that the public are very aware of this. Some of them are very reluctant, even scared to have AI be involved anywhere in their treatment. It's not something we're prepared for. It's not something we have the ability to deal with. Can we, treat people differently depending on their preference for technology? I can't see how that could possibly be practical in an organization like ours, certainly. But these are the things that we have to contend with. It's not just, can we do it safely? Is it going to make the world a better place? It's, do people want us to? And their opinions, maybe not particularly well informed, have to matter to us. So those are our challenges with taking stuff forward in this space. We've got the classic regulations that we've always had that help keep us safe and legally compliant. GDPR, Data Protection Act in the UK. These are already starting to cause us problems. Whenever we try and do anything with an AI product, the first thing from the company is, send us a load of your data and we'll decide whether it's going to work or if we can tune it to do their job. We have no legal basis for undertaking that piece of work, really. We can treat patients. We can use anything we have of their data to treat them. But when it comes to using data for service improvement, that's not so obvious. And if it has to be identifiable data, or indeed we can't de-identify it effectively, then we get into a whole legal nightmare about what we're allowed to do with that data, even if it's to try and develop hospital services. We have a research process that lets us do it. So quite often we're calling things research projects that probably aren't technically research projects, so that the data governance processes can be followed because we have a framework for those actions. But it's actually really quite challenging the way AI projects work, the way vendors work. They want all your data to see if they can do a job before you buy something from them. And until we have a product, we struggle with data access to vendors. So that's a really big challenge for us. We have a lot of regulation on production of software, which is fine. You've got your CE marks and your UK CA marks, which is our equivalent now. Those are usually underpinned by some quality assurance system, whether it's ISO 9001 or one of the other ones. We're starting to find that those are increasingly challenged by AI products. They're built for devices, and whilst lots of medical software can be thought of as a device, as soon as we move into the world of large language models, as soon as we move into the world of systems that are non-deterministic, things that give you a different answer for the same input every time, these processes start to fall down. What does testing even look like when the next time you ask the question, you don't get the same answer? And you can come up with statistics and massive brute force strategies, but they're all a bit unsatisfactory. Increasingly now we're moving back to the clinical safety standards. What can go wrong if this thing doesn't do its job right? What safeguards can we put around it? We're moving to starting to treat these things like a fallible person rather than a computer system that is going to do what we want it to do every single time. Now, none of these things are new. But the shift in focus in our organization, certainly away from those accreditations for medical devices to what are the critical safety processes that we need to have in place to manage them, is quite marked over the last few years. From our UK bodies, they've been doing tons of research. If you go onto any of the UK NHS websites and search for AI, you will get lots of work done on evaluating what performance looks like, evaluating safety. They're all starting to say we do need some specific AI regulatory guidance. One of the things that are often missing from products, which we would desperately like to see, is confidence scoring. They'll give us an answer, but how confident are they? If you can do that, that's a massive step towards adoption, because then it's not such a black box. We don't know what it's doing, but if it can have some confidence behind it, that would be a real selling point, I guess, getting people comfortable with the concept of using these things. Explainability, I guess I don't have to tell most of you what that means. Strong human oversight. Interesting. Of course, human in the loop is the phrase that we all use. Only the financial model for most of these products is getting rid of humans, right? They cost a lot of money. You can't just pay for a thing and then have a human do the same thing again to make sure it's done the job right. How does that start to even impact on the business cases that we have to put forward for these services? It's really quite challenging sometimes, especially with massively increasing costs. And post-market surveillance is going to be a huge regulatory process. You can't just put something in and leave it there for 10 years like a database application or something we used to do. You have to really start looking at how these things perform on real world data in a changing organization. Our organizations change a lot, and therefore the performance of the algorithms will change a lot. I've started trying to describe these algorithms as virtual employees rather than computer algorithms, because if you take on a person, you don't just sit them at a desk for 10 years and expect them to do their jobs forever without ever failing. You have processes to check on them. You have appraisals. You have audits of performance. You do all these things with a person. And I'm trying to get people to realize that you probably have to start having processes like that around big systems, especially where they're using LLM type technologies. And risk assessments that are proportional is always a medical imperative. I think that, So the things that we still don't have answers for, certainly in the UK, liability is a huge problem. When a software goes wrong, whose fault is it? Well, if it's deterministic, usually you can track it down to the vendor or the operator. When it's got a whole load of randomness in it, and did you give it the right input? Was that what it was expecting? It gets very, very blurred and very contentious. And then we've got agentic AI coming in, which just compounds all those problems by a factor of X, agents all behaving in a largely non-predictable way. So these are the things that the UK government through NHS England are currently realize they have problems with, but really haven't even started to think about what the solutions to those things might be. So that's kind of a whistle-stop tour of where we probably are in the UK. More questions than answers, I think, but asking the right questions is always a good starting point. And I think we're getting close to understanding what the challenge is, at least, if not having all the answers yet. I'm going to pass you on to John.
Great. Thanks, Woody. So I'm going to move on to evidence generation, which is something we spend quite a lot of our time thinking about. It's a large part of the consideration when you bring AI tools into a hospital. So I work in imaging as a medical physicist. So my examples are all from imaging, which is where AI is probably the most embedded in terms of directorates, but the kind of lessons learned apply to other directorates too. So first, I thought it'd be good to give an overview of what kind of imaging we're actually using in our hospital right now. And it is quite representative of other hospitals too, I think. So firstly, we use a lot of AI for segmentation, for drawing around things in images. Convolutional neural networks work really well for this kind of application. Definitely makes segmentation a lot quicker and reduce interoperator variability. And there's quite a lot of evidence to show that. It's quite a low-level risk kind of application, I think. So we've developed quite a lot of in-house applications for this, for more niche areas like kind of nuclear medicine, heart scans, cardiac heart scans, also for total liver and total kidney volume measurements, also for segmenting liver for like radiation treatment. So lots of in-house applications. We also have commercial tools as well, which are becoming increasingly available. So that's definitely well implemented, and it's the same in lots of other trusts in the UK and worldwide as well. Another area where it's started to come in quite a lot in imaging is in image reconstruction, actually. So, for example, our PET CT scanner will use a convolutional neural network to do like denoising after reconstruction. And you have similar things in MRI, also CT. And this is a little bit different in that they kind of come with the device and you install it and they're kind of turned on by default. And I don't think people are quite kind of prepared on how do you actually acceptance test these things. Because quite a lot of the time the systems are built so that you almost have to use this, like it's the default. But it's really hard to check it's doing what you expect, because you can't just use phantoms like you used to do for old image reconstruction algorithms, because it's trained on patient data. So you need test patient data. But yeah, it very much has come into hospitals and is going to become more and more used in imaging reconstruction to reduce time, particularly. And then in Sheffield in particular, we do a lot of evaluation of classification tools. So bits of commercial software which will try to detect disease on an image to maybe triage. So, you see a patient with an abnormality quicker and therefore theoretically get to a diagnosis quicker or treatment quicker. So yeah, a lot of evaluation work that we're doing on that side. But this is kind of representative of where we are imaging, I would say, in the NHS. I'm now going to go through an example of some of the kind of checks that we did on chest X-ray AI solutions when we were thinking about whether we might want to get that kind of AI in our trust. Just an example of the kind of work that we were doing. So this is all based around lung cancer, which is a major healthcare issue for us. I'm sure it is in Poland as well. It's the third commonest commonest cause of cancer deaths. And it's largely, there's a big influence, of health inequality. The most deprived people have the highest rates. And early diagnosis is obviously important. If you catch the disease earlier, it makes a big difference. And chest X-ray is a really important part of diagnosis. We do over 8 million chest X-rays annually in England, and it's a critical entry point in the diagnostic pathway. If you present with symptoms to a GP, you may well be sent for a chest X-ray first, and if you see abnormality on that, you might then go for a CT, and then further down the line, hopefully a diagnosis. So a lot of images are produced. Problem is, time to reports is longer than we'd like it to be, should we say. I've got a little graph here from 2019, and I'm sure the times are worse than this, but chest X-rays can, take several days to get reported. The follow-on CT can take several days to a couple of weeks to get reported, and that's pushing down the timeline of when your patient actually gets diagnosed with a cancer. And of course, there are workforce shortages in radiology as well to worry about. So over many decades now, people have thought, could AI help with this? Which is, a huge volume of data, not enough people to look at the images, essentially. And the current landscape of AI for chest radiographs in the UK is kind of interesting. There's a lot of different commercial devices you can buy. This slide is a little bit old now, but just represents some of the different manufacturers you can go to pick up an AI tool. And actually, our government is very keen on AI to, reduce costs and improve diagnosis times. And a few years ago, they introduced a diagnostic fund, which basically gave £21 million to 64 trusts across the country to roll out AI diagnostic tools, and in particular for chest X-ray, actually. So lots of trusts bought these tools. And actually what ended up happening is that some vendors have quite a large market share in the UK. So Annalise, or Harrison as it is now, claims to process a third of England's chest X-rays. And actually, I think it might even be higher now. At the same time, though, there are evidence gaps. So people have been trying to create tools to automatically classify chest X-ray images for decades now, like well before AI. But really, the evidence out there is not that great. And so NICE relatively recently looked at all the evidence from AI tools and how much impact they make, and decided they still weren't going to actually recommend AI tools in chest X-ray, despite the fact that the government's given out lots of money for just that purpose. So internally in Sheffield, we're thinking, okay, there's money out there for these kind of tools, and we're probably going to end up implementing them at some point. How do we select which device to use? Because understanding how performance compares between devices is really critical. If you select the wrong bit of software, things can go wrong, patient harm, resource waste, and also damage to the field. So, maybe next time you come with an AI tool, people are much less willing to kind of take a risk with it. And there's very few comparative studies, as I kind of alluded to already. They often have small sample sizes, enriched data sets where there's lots more abnormals in the population than you'd actually see in reality. and limited statistical comparison. So in this little study we did, we aimed to compare the diagnostic accuracy of multiple devices for lung cancer detection. And importantly, in a representative cohort with real-world disease prevalence, which isn't often done. So we took over 5,000 chest x-rays with reports that were labeled and MDT outcomes. That is the decision from the multidisciplinary team whether they really did have cancer or not. We put them through a platform which basically sent out that data to 7 different vendors and 12 different models. We got back a CSV file and image captures from all of those vendors, and we analyzed all of them. So that's a lot of data, sending out 5,000 scans to 7 vendors, 12 models. Each of those will send back 5,000 sets of results. A lot of statistical testing we had to do. And just to show the kind of things that we did to label our data and curate it, we got our radiologists to draw on the image where they thought the abnormality was, so we could check not only at an image level whether the tool was classifying the image correctly as abnormal or not, but whether it identified the right thing in the image as well. And I'll just very quickly show some results. So this is a graph of sensitivity against specificity for all those different models. And you can see there's a really wide variation here. The black R is the radiologist. And what you can see, there are like 4 models here, which actually, if you chose them, the best performing one, you would have detected 9 more cancers over that 5,000 chest x-rays. Whereas the worst performing algorithm, if you'd gone with that instead of a radiologist, you would have detected 28 fewer cancers. And when you consider, I think there are only like 90 cancers in that 5,000 patient cohort, which is pretty typical, that's quite a big impact. If you look at positive predictive value against negative predictive value, again, you see a big variation with the radiologist being kind of at the top there. And this is quite stark, I think. So those best performing algorithms, if we'd used those, we would have got 66 more false positives. So that's 66 patients who may have gone on to have a chest CT when they didn't need one. Whereas if we chose the worst performing one, that had over 2,000 more false positives. So that's a very high rate of sending people for a CT who don't need one. And also, there's actually quite weak agreement between the results from different vendors, which is quite interesting. And some of the outputs are quite confusing as well. This is something that doesn't often get into kind of accuracy results, sensitivity. How is a human actually going to interpret these results? If you look at the image on the right, for example, you've got loads of different boxes, lots of different text on the right-hand side. Like, how is someone meant to kind of interpret all of that stuff? So I think the key messages from this bit of work, which is kind of representative of the stuff we're trying to do in imaging, performance can vary significantly between devices off the market. And that has implications for your selection process and choosing the right device for specific pathways in your hospital. We found kind of 3 potential devices that might work okay for us, but we now need to do prospective testing to see what are the downstream impacts. There might be, unintended things that happen. Would we actually save any time overall, save money? So we've now got a £1 million grant to do a multi-center randomized control trial across our region using 200,000 chest x-rays. And I think this is an important bit of work in advancing the field because not many people do kind of multi-vendor benchmarking. They just pick one off the shelf and assume, okay, this represents the whole field of AI. But I think we've shown that's not true. We need new strategies for robust comparison. And this leads on to recommendations for output harmonization as well. And just to say, there are many other applications where AI is being sold and used in hospitals in a similar way. So, for example, in head CT, like we in Sheffield use something called Rapid AI, but there are other vendors too, to decide whether an intervention needs to happen for someone who maybe has stroke. There's applications in lung CT, in thyroid, ultrasound, lots of other different areas with the same kind of classification approach and probably have the same issues that we've described here and more. So that's some examples from imaging of the kind of evidence that we're looking at. Now we're going to move back to Woody for part 3.
So I'm going to come on to some of the problems with these things, kind of following on from what John's just said in terms of the unintended consequences of dropping a technology into a process that's not ready for it or that hasn't considered the knock-on effect. Because these are transformational algorithms, right? They genuinely are. But in an organization that doesn't really understand how transformational, they can lead to almost more problems than they solve. So this is John's example. We have analyzed chest x-rays for signs of a tumor, automatically send any pathologies or suspected pathologies for a CT scan to confirm. Well, what's the benefit of that? Well, firstly, the benefit is if we can do that quickly enough while we've still got the patient, they can go for a CT there and then. That means they're not waiting a couple of weeks longer just to get the CT scan, and then it has to be reported. And also there's potential accuracy, as in it picks up more than a radiologist or indeed a radiographer who's doing the imaging might have picked up. So as John's already described, there are good reasons for wanting to do something like that. The downsides are, in general, for most AI things, because the focus is on safety and not missing cases, sensitivity is prioritized over specificity. Problem with that for us is that prevalence is a real issue. So we have loads more people who aren't sick or don't have lung tumors than do when we do CT, when we do chest x-rays. So what this leads to is a massive increase in the number of CT scan referrals, which John's already said. Now, one of those problems might be, well, we just get the AI to read the CT scan as well if we don't have enough radiologists to cope. But the AI isn't going to buy us a new CT scanner. We don't have the capacity. So if you've got, a specificity of 99%, 1% of the scans are going to go that actually don't have a tumor. And even in 10,000, that's an extra 100 CT scans. And the numbers are way bigger than that, 8 million, as John's already said. So we do not physically have the infrastructure or the human resources to respond to the demand that this algorithm is now going to put on the system in the hospital. And these are problems that really do impact on things. People have turned the algorithms off for this reason, because they can't cope with what comes next. So if you're designing something, you do have to really kind of get into the weeds, as it were, on where in the care pathway this is going to be used and what the impact might be on both the staff or indeed the infrastructure that we have. The next one is not imaging related. It's prioritizing treatment waiting lists, which sounds like a great thing to do. We can look at all the patients who are waiting for an intervention and say, the people who are most in need will get to the top of the list. And, this is the positive slide, right? I don't need anything else on this positive slide. Those most in need get seen first. It kind of seems like a completely no-brainer decision-making process. Only it's not really that simple, because in a resource-challenged system, the result is you only see people once they've become very ill. Until you make it to the top of the list in terms of illness, you don't get treated. The second statement is equally true. We absolutely know that in most diseases, intervening earlier, before you're terribly ill, costs less money and has better outcomes. So the kind of philosophical question of how we prioritize things is really, really difficult to answer. And it's not obvious. I don't have an answer for you today. It's obviously going to be somewhere in the middle of the scale, but these algorithms are pushing you to an end of the scale. They're pushing you to an order which they think and can sell as a very simple statement to people who haven't really thought it through properly. This is what you should be doing. It's probably not all you should be doing. And without people who are really thinking about the whole healthcare system, the economics of a nation, you can't really make decisions about prioritizing people based purely on ill health. You have to do more than that. You have to be smarter than that. And these algorithms aren't. And that's largely the people who are developing the algorithm need to be more cognizant of the economics of it, especially in the UK, where, we are not particularly well funded in the NHS. And the final example of kind of unintended consequences is automated flow analysis of coronary arteries. There are a couple of these around. Some of you will have heard of the major commercial examples. They take an image of the cardiac arteries, they analyze the flow characteristics, then you make an objective decision about whether you're going to intervene or not. The idea being that if it costs a lot of money to intervene, there's risk with it. Maybe you can get by with a small thinning of the arteries, or maybe you have to go in. It has good performance in terms of specificity and sensitivity, and also expresses a confidence stroke certainty in its response, which is really good. These are the kind of characteristics that I described at the start of us wanting to see in algorithms. However, when you put it into service, we get feedback from our consultants like, it's very good at telling me which ones I don't need to intervene with, but I already knew that. It's very good at telling me which ones I do need to treat, but they already knew that as well. And for the small number in the middle, that the consultant will struggle with making a decision as to should I treat, should I not treat, the algorithm returns a very low certainty as its answer. So essentially, it's as equally challenged by these cases as the consultant. And it costs a lot of money. And what is it actually giving us in terms of benefit and treatment? We've still got the consultant. They still have to do all their things. We bought an algorithm that doesn't really tell us any more than we had. And that's because the test sets are massive, right? And the ones in the middle, there's a small sliver, and they're the ones we struggle with. But those aren't the ones that are predominant in the statistics of performance. So these are all things that we've done or are doing that we really should be stopping and thinking about in more of a system-wide approach. Understanding where in the care pathway your tool is going to be critical to its success. Improving efficiency or throughput sounds desirable, but if the bottleneck just shifts downstream, the benefits won't be realized. And in our world, we get paid by patient. If they still take as long and we don't see as many, then we're just paying a lot of money for an AI solution. Really doesn't start to deliver the increase in patient seen, which is what our major goal is most of the time. And with AI costs increasing all the time, and if we're insisting on humans in the loop, where does the money come from to pay for the algorithms? It gets very, very difficult to understand the financial model for these things. I mean, everyone is arriving at the conclusion that the financial for AI in general is challenging, but in healthcare it's even more complex because we have so many factors sitting around these algorithms that it's really, really difficult to understand whether we should invest or not in some of these technologies. And we're back to John.
Thank you. Okay, so I'm now going to talk about our AI implementation framework that we developed. Why do we even need a local framework? There's lots of documents out there. Why can't we just take, stuff that's in the literature about an AI tool? Hopefully, you'll have realized from all the things we said, it's really not as simple as that. And it largely comes down to the fact that we don't really know whether an AI tool will be accurate for our patients and work well in our particular systems kind of ahead of time in the vast majority of cases. Like we have a particular PACS system, got particular EPR, different IT infrastructure, and our patient flows might be different to other hospitals. So we need some guidance there. Also, the person leading a deployment is going to likely need some guidance. Usually the people wanting to bring AI tools into a hospital are doctors, clinicians who maybe, they've been to a conference and they've seen something that looks good, might be helpful for them. Get this through procurement and start it and it'll be great. But all the stuff around, how it links with IT, cybersecurity, DCB standards, risk analysis, that kind of stuff doesn't come into their mind. So having some guidance on how to think about all this wider stuff is going to be really vital. And in the end, having a framework ideally should enable successful deployment of good tools that are useful, either save money or improve care, whatever it happens to be, using a consistent approach that is hopefully transparent as well. And importantly, avoiding AI tools that won't work well for us. There's lots of examples out there of people buying AI tools that haven't worked. When you talk to other centers, well, certainly when I've talked to big centers that have implemented a lot more AI tools than we have, they tend to say they reject the vast majority of suggestions for AI tools that should get implemented because it just doesn't stack up in terms of the money saved or downstream consequences. And lots of frameworks have been developed in the literature from like case studies and stuff, but they don't actually say exactly what and how the user should go about implementation in our local system. So that's kind of why we came up with this local framework. And I must say, this was all done by my colleague, Ellie Hesketh, who spent a year doing this. So I basically stole on her slides. What she did, first of all, was do a literature review, see what's around there in terms of the case studies, guidance from different bodies, come up with a draft of what a framework might look like for us. And then she got a lot of feedback from an AI expert group, which included myself and Woody, but others, and also all the kind of stakeholders that might be involved. And then a final version taking into account all stakeholder feedback, but also some public involvement and user feedback. So the kind of people that are going to have to go through this probably relatively laborious process of bringing an AI tool into the trust. What do they think of the guidance? So what does it include? Well, there's mandatory steps alongside guidance and good practice. And the people leading a project in our terminology are called like AI project champions. And then there's a separate AI expert group to provide support and advice to these champions. And I'll just mention now that this documentation, this framework, this is something that I was have shared with Sano before and very willing to talk through again. So I'm not going to go into detail about every single part of it, just giving kind of like a high level overview. And the idea is that you have these different stages where at any point you can kind of stop that product and sort of switch it off to kind of minimize losses, I guess. So you have initial screening and project initiation where you check based on kind of like a desktop exercise, is this ever going to work or be viable in our setting? And then you move on to like pre-deployment and validation, which might involve some testing with local data, clinical deployment, maintenance, and then finally decommissioning, which is something that people often forget about. So if we just kind of step through those sections one by one, we give out this screener questionnaire to people to fill in. And this is about, how likely is it that the AI tool will work well in Sheffield teaching hospitals? And has it got directorate support? Do people in that area of the hospital want this tool? And is it a real problem that needs solving? And these are some of the questions that we ask. This is very much not all the questions, just a small subset, just to give you an idea. So things like, what's the problem you're trying to solve? Does the output from the AI tool enable the user to take practical action? And does that action solve the problem you're trying to solve? Sounds simple, but often people don't think of it in those terms. What clinical validation testing has the manufacturer done on the tool? What were the results? Is the AI tool designed to interface with hospital IT? How will the user access it? What types of data does the AI tool need to work and what format? So we're getting at, how is it actually going to integrate with our systems? Does it actually solve your problem? And then assuming we get past that phase and it all seems okay, there's the kind of pre-deployment and validation where we're looking essentially, how well does it work with the STH data? So maybe we take some example data, run it through the algorithm, see if it gives the kind of answers we might expect. We're also looking, could there be any wider problems? So information governance, that Woody's already talked about, is an issue. Sending data all over the world to be processed, which is very much identifiable. There's issues with that. Assessing impacts, downstream impacts. Also wider stakeholders. The person buying the tool isn't necessarily the person that's going to be affected by the outputs from the tool. And then, finally, evaluation as well as a kind of whole product. And only then, after you've gone through that and procurement, then we get onto clinical deployment, where you've got to do things like potentially IT and PACS integration, which in itself is a fair bit of work. Training is something really key that people often miss out on. If it's an AI tool that's going to be used, say in chest x-ray, there's a lot of radiographers in our trust who do chest x-rays and they change fairly frequently. So you're going to have an ongoing scheme for training them how to use it, and also the radiologists how to interpret the results. You've got contracting, key performance indicators. You've got to think about what kind of things we're going to measure to see whether this has been a success over time. And we generally recommend like a pilot rollout, so like a small scale rollout of the tool before going on to tool deployment. This is all about starting to use the tool clinically in a controlled way once we've done all this kind of testing. Then we've got maintenance. So doing audits, service reviews over time, assessing for external algorithm drift. Also updates to the AI model and algorithm. Quite often when you buy these tools, the vendor will want to update that model every, 6 months, a year, but that could completely change its performance. So you need to make kind of a risk-based assessment of whether you want that update to be applied, and if so, what kind of testing do you need to do to check it's okay? So essentially this is all about, does the tool continue to perform well over time? What impact has it had historically as well on clinical services? Is it giving us value for money, continuing to give us value? And then finally, decommissioning. So, contract review, termination, cancelling deployment, uninstalling stuff, basically carefully stopping using the tool. So those are the kind of 5 sort of stages. You can see there that that's a lot of work to go through for a single tool. One of the things we did was give this framework to kind of stakeholders, users, to get their kind of feedback on what they thought. And some of it was very positive, like, comprehensive, thorough, covers everything. Good to have everything in one place. Good to have the guidance on dealing with software and algorithm updates, which is good. But obviously there are some challenges too. So an obvious point, will people really have the time to do all this? It's a lot of work. And it definitely is. You'd have to be, really positive about the potential impact a tool is going to have on your service to want to take it through this process. And that's kind of part of the point. We want people to only bring in stuff that really is going to work. Again, it might put off people and stifle innovation, is an argument we've heard. What about finance and procurement? I didn't really talk about that here. And there are some issues around procurement in that we have, particularly in the UK, and I think it's the same in Europe, quite rigid controls on how you do a procurement exercise. And doing kind of evaluation with test data as part of that doesn't really fit into that workflow. And also, why do we have to do all this if other centers and departments don't? And I think it comes up increasingly and is an interesting question, because there are certainly hospitals near us that haven't done anywhere near as much of this evaluation and just kind of started using AI tools. But there's also a lot of stories of people turning off AI tools because they didn't do this work as well. So I think there's a very high chance you kind of waste your money and put people at risk if you don't do this kind of. And just to say that we have in our trust a governance group, an AI and imaging governance group at the minute, which is formed of people in Woody's group in scientific computing, people in the 3D lab, which is where I work in imaging, image analysis, also people from the University of Sheffield, and some people from the wider trust as well. And we're kind of there to provide guidance on all this stuff to help people along, but not actually do the work for them, just kind of provide that guidance. And it's a similar model in other hospitals in the UK. But ultimately, we want this advice to be for the whole trust. It's not just in imaging. We want it to be applicable to anywhere that wants to get AI into their particular part of the hospital. So we're moving towards like an AI hub model. And after throwing all that information at you, I think that's probably about it. In case people want to contact us, ask us questions, we've got a 3D Lab website, people are interested. But essentially, I think we're ready to take any questions.
Well, John and Steve, many thanks for your talk. It was a very I think that very practical approach to this. And the question which I have at the very beginning is to which extent it is your experience in Sheffield, and because in the title you had the whole UK National Health Service, so is it based on just on Sheffield experience, or it is also enhanced with some other hospitals?
Do you want me to start on that one?
Yeah.
So I think there are some things that are quite consistent with other hospitals around the country. I'm an imaging person, so that's kind of my area. That's the only area I know about. But there are lots of other hospitals that are trying to do good AI implementation, as in, check properly the evidence and the downstream impacts. They tend to be larger hospitals, I would say, like teaching hospitals, where they kind of, maybe have scientific computing teams, maybe have more scientific teams. There are other hospitals that don't go down this route, I would say, as well. And in general, from what I've seen, they are smaller hospitals that maybe don't have the expertise in particularly the technical side, and are maybe more influenced by salespeople, possibly. I would say our experience is quite representative of larger hospitals and what they're trying to do, but maybe less so the smaller ones. I don't know if you've got anything to add to that, Woody?
No, I'd agree. It does seem there are kind of very much two types of they're the big university hospitals where we can draw on the expertise of our university colleagues for kind of theoretical grounding and descriptions and explanations and education. So I get taught all the time by the computer science guys about how these things work, which then I can apply to critically evaluate products. And like John says, London and all of the other big teaching hospital centres have a similar model of that support from their academic counterparts in the city usually, whereas lots of the small hospitals are at the whim of very good salespeople promising them the earth, which is why we need to get our learning up to that national level and formal guidance and even rules to kind of tell all the rest of the people, this is the benchmark, this is what you have to meet to do this safely. Because until that comes down from the top, it will be a very mixed economy of hospitals.
Thank you. And I'm also, we have a question from Maciek Malarski. Maciek, please go on.
Okay, hello. Thank you for this presentation. And I have one remark, maybe comment. So we recently observed that there are many medical professionals, doctors, physicians at the hospitals or other places who start using these AI tools, including, some of the chats and other ones, which is of course simple, but even those more advanced ones, like some tools for coding, to develop their own prototype of actually medical software tools, and then they are trying to test it, of course, on some patient data that they have, sometimes maybe not officially. I mean, this is some anecdotal evidence, let's say. And yeah, on one hand, it's a threat, yeah, but on the other hand, it kind of simplifies this interaction between the medical doctors and the engineering teams because they can show us, yeah, how these tools they would like to have, they should look like, yeah. They give us some prototypes and so on. And yeah, my question is, do you also observe this kind of cases, and do you think it actually helps or harms, or how is it?
I have observed it. I mean, the sort of chat GPT thing, give me a differential diagnosis based on these symptoms. It's quite terrifying but with the chat tools at least, the line is always kind of clear about where the clinical responsibility is. So there's some things that I'm less concerned about than others. People developing their own apps is really scary. I mean, it probably couldn't, in our infrastructure, in our hospitals, everything is so closed that it would be very difficult for someone to do that. I've never seen anyone do that, actually. What I have seen them do is modeling tools, which arguably is just as dangerous. If you start running your business on models, business models, the number of patients, demand, all that stuff for things that aren't validated because you didn't really understand what you were doing, it's really quite scary. Yes, and that's where the education for us comes in. We're trying to set up programs of education for people to try and teach them just how fragile vibe coding is. Let's just put it all under vibe coding. And how they really shouldn't be doing it without some kind of formal framework. I mean, relationship with you guys, right? That's fine. If someone wants to vibe code a front end, so you've got some idea of what they want better than them describing it to you and you interpreting, that's fine. But yes, it's quite a scary time. I think cost keeps most people away from doing it, apart from the consultants who obviously have loads of money to spare. But yeah, we need to get a handle on it. It's not okay, don't think, in most cases, but we can only do it through education. We just can't stop it. So we have to teach people their responsibilities, and if they want to do it, learn how to do it safely. I don't want to stop them. I just want them to be trained properly, and if they want to take the time out to do that, then I don't really have a concern with it.
Might be worth adding that some hospitals have, as an interim solution, chosen to like turn off access to ChatGPT, for example, from inside the trust. But kind of going against that, NHS England bought 500,000 Copilot licenses. So like there is easy access at the same time. So there's kind of mixed messages in many ways. And the education piece is very behind, I would say.
Okay, maybe I will have one follow-up question. Yeah, because when you mentioned about this, blocking of using external, tools like chats and so on, the other solution would be to have something, installed locally in a more controlled environment with those, smaller local models. So is there any initiative to do this kind of maybe testing or pilot studies that you are aware of?
I mean, we do have some local resources to try and set up things, but for the chat stuff, well, firstly, most consultants just use their personal phone with their personal internet connection, so we have no control over that. Like John says, we've already bought a lot of Copilot licenses, which we are not explicitly managing the use of. Lots of them are going to be used by managers to produce documents for sure, because that's what most people want to do with it. But the consultants will still have access to them. They will still be able to ask those clinical questions. So whilst we are, let's say, controlling the data governance of it, it's with a certified vendor who we trust, Microsoft, who have, all sorts of provisions in place for not stealing our data and absorbing it into their models, etc., which you may not have with other providers. It's not just about controlling the governance bit of it. It's about controlling the use and interpretation of it by our staff. And that can only be education, I think. But like John says, we are very behind in those terms because everything changes so quickly.
Yeah, okay. Thank you very much.
Thank you very much. And I have a question about the tool. In your presentation, you had a kind of a comparison of different tools, yes, and well, can you tell more about these tools? Have they been, let's say, allowed to be used in the clinical practice, or they were somehow experimental? Or...
So if you mean with the chest X-ray tools, yeah, these are all commercial tools. They're CE marked. You can buy them.
No?
There are hospitals around the world that have bought most of them. So, and there's been randomized control trials based on, different ones, but they've obviously got different performance characteristics. So, yeah, it's kind of crazy to me that people see like 12 different algorithms and they just pick one without really like, how do you know that was the best one to buy? But yes, they are all in use in hospitals around the world.
So I think that what you have presented indicates that it's better to use not just one specific tool, but maybe to use 2 or 3 of them at the same time, or well,
Maybe, but then the cost of these things is a lot
yes, so
per
this is the
scan.
problem.
And already the kind of financial benefit is probably quite small. So if you're doing 3 at a time, and then how you have to think about how that would work in practice, because generally you need an answer very quickly. If you take an X-ray, it's a very quick exam. You want that result within 1 or 2 minutes. So, and then how do you combine those different outputs? Because also each vendor will tell you about different conditions. So like one algorithm gives you 7 kinds of disease. Another one gives you like 140 different kinds of disease. So like they don't necessarily cross over in terms of what they show you as well. I think your thinking is good. Like having that kind of uncertainty analysis between different tools is good, and we use that in segmentation actually internally. There's an idea, and I think it is a good one, but it's just practically how you would do that with commercial tools is very hard.
And then you get into actual infrastructure issues like bandwidth. We have to send these things off to 3 different cloud providers every single time we take a chest X-ray. It just puts a massive load on all of our things. And these are things that often get missed, right? Because you look at the numbers, you look at the performance, you look at the clinical benefits, but we don't really consider infrastructure until the very last minute when actually someone implements something and all of a sudden everything starts creaking. It's all so complicated.
And when using such a tool, you have finally you have a consultant in the process, yes. So I understand that all these commercial tools do not allow, let's say, to introduce modification based on the knowledge on the consultant, yes?
So do you mean to report independently of the consultants?
Mm-hmm.
Yeah, so that is currently not allowed, particularly for ionizing radiation. It's specifically forbidden under the law that you can have anything that isn't looked like by a human. You can do prioritization, so you can get humans to look at sicker patients, like Woody was saying, but whether that's a good idea or not is another question. But people are doing studies and trying to introduce the idea of independent reporting. I think that's obviously where the companies want it to go, because then the value proposition becomes much higher if you get rid of humans. But I think it's going to be very hard for them to persuade people in charge of the laws that that's a good idea. But that is where they want
all the patients.
All the patients, yeah.
So, well, I think that one of the important contribution of your talk is this a kind of checklist which you have somehow presented here in the talk, and I think that it for such a scientific institution like Sano, it is very important from the point of view that our colleagues working on different methods of artificial intelligence for usage in medicine can, let's say, see what will happen in the future in such a tool. So it is really a great value of your talk. So I'm very grateful for it.
Yeah, and our intention is to come to Sano as well and talk through this stuff in more detail, and to maybe take one of your tools, your bits of software through our framework to see, okay, what would the specific issues be for your particular tool? So yeah, we'll hopefully carry on this conversation.
Yes, it was really very, it is very useful. Fortunately, your talk is recorded, so we will look at this from time to time. Many thanks for your contribution. Many thanks for your talk, and thank you very much. And we will have the last seminar this summer semester in a week from now, and then we'll have a kind of holidays. Oh, we had on the chat, we had something from Andrew, who wrote that it was a great talk. Oh, it was a very short.
Thanks, Andy.
Thank you.
It was a bit longer, but I made it short. So many thanks. Thank you very
Okay.
much. And
No problem.
bye.
Thank you very much.
All right, see you. Bye.
Bye.